For centuries, one question has puzzled historians, engineers, and scientists alike. Why do some Roman structures still stand strong after 2,000 years, while many modern buildings begin to crack within decades? Across the Mediterranean coastline, ancient Roman harbors continue to face relentless ocean waves. Salt water pounds against them day after day, storm after storm, century after century. Yet somehow, the concrete refuses to crumble. Meanwhile, modern concrete structures often struggle to survive even a fraction of that time. Bridges crack, seawalls erode, reinforced concrete begins to deteriorate as steel inside it rusts. So what did the Romans know that we seem to have forgotten? The answer lies in a remarkable material that ancient engineers perfected more than 2,000 years ago: Roman concrete. Unlike modern concrete, Roman builders used a mixture that included volcanic ash, lime, and chunks of volcanic rock. This material was known as pozzolana. When mixed with seawater, something extraordinary happened. Instead of weakening over time, the concrete actually began to transform. Deep inside the material, rare crystals slowly formed. These crystals filled cracks and strengthened the structure from within. In other words, the concrete could slowly repair itself. Modern scientists call this phenomenon self-healing concrete. But for the Romans, it may simply have been the result of careful experimentation and observation. Recent scientific studies have revealed that when seawater seeps into Roman concrete, it triggers chemical reactions. These reactions produce minerals such as aluminum tobermorite. This rare crystal strengthens the material and helps prevent structural failure. Incredibly, these reactions continue for centuries. That means Roman concrete doesn't simply resist damage, it becomes stronger over time. Modern concrete works very differently. Most modern structures rely on steel reinforcement. Steel provides strength, but it also introduces a serious weakness. When water and oxygen reach the steel bars, corrosion begins. Rust expands inside the concrete. Eventually, the pressure causes cracks. Over time, the structure weakens. This is why many modern bridges and coastal structures require constant maintenance. But Roman engineers approached the problem from an entirely different perspective. They designed their concrete specifically for the environments where it would be used. In coastal areas, they built massive harbor structures using volcanic materials that reacted with seawater. These reactions created a chemical bond between the concrete and the ocean itself. Instead of fighting the sea, Roman engineers turned seawater into part of the construction process. It was a brilliant solution, and it worked. Even today, many Roman harbors remain remarkably intact. Some researchers believe that if modern engineers adopted similar techniques, we could dramatically increase the lifespan of infrastructure. Imagine bridges lasting hundreds of years instead of decades. Imagine seawalls that grow stronger instead of weaker with time. But recreating Roman concrete is not as simple as copying an ancient recipe. The exact proportions, materials, and building methods used by Roman engineers are still being studied. Different volcanic regions produce slightly different minerals. The Romans may have understood which materials worked best through generations of trial and error. There is also evidence that Roman builders intentionally used large chunks of lime in their concrete mixture. For a long time, scientists believed these lime clasts were simply the result of poor mixing. But new research suggests something very different. These lime fragments may actually play a key role in the self-healing process. When cracks form, water reacts with the lime and creates new minerals that seal the gaps. Once again, the structure repairs itself. It is a remarkably sophisticated system for something created more than 2,000 years ago. And it raises an intriguing question. How did ancient engineers develop such advanced knowledge of materials? Roman builders did not have modern chemistry laboratories. They did not have electron microscopes or advanced testing equipment. Yet through observation, experimentation, and experience, they created a material that still outperforms many modern equivalents. Today, scientists around the world are studying Roman concrete in hopes of unlocking its secrets. If we can fully understand how it works, it could revolutionize the way we build. More durable infrastructure, lower maintenance costs, and structures designed to last centuries instead of decades. But perhaps the most fascinating part of this story is what it reveals about ancient engineering. The Romans were not simply builders, they were innovators. They studied nature, they learned from the environment, and they developed technologies that were perfectly adapted to the world around them. In many ways, Roman concrete reminds us that progress is not always a straight line. Sometimes, ancient civilizations discover solutions that later generations forget, and sometimes the past still holds answers for the future. Even after 2,000 years, the mystery of Roman concrete continues to inspire scientists, engineers, and historians, because hidden within those ancient harbor walls may be a lesson modern civilization is only beginning to understand. Sometimes the greatest technology is not the newest. Sometimes it is the oldest.